welcome back. So one of the things that we will spend some time talking about in evolution is the geologic time scale. The Earth is guesstimated by scientists to be about 4.5 billion years old. And in that span of time, there have been millions upon millions of species that have lived here and then disappeared. And scientists will use the data they collect from learning about rocks, learning about fossils, things like that, to establish time periods. And they use fossils, a lot of fossils of things that no longer exist on this planet in order to get their information about time periods throughout the history. And that's what we are going to be talking about over the next couple of days when we talk about the geologic time scale. All right, so scientists think that life actually began somewhere between 3.9 billion and 3.5 billion years ago. Okay, that's when they think we got the very first life actually on this planet, so the first cells. Okay, and they get that number from the fact that the oldest rocks that they have ever found on the planet were dated to about 3.9 billion years old. Now, they have scientific basis for this. They can use something called radioactive dating. Radioactive chemicals, isotopes, atoms, disappear at very set rates. And scientists know how fast they disappear. And so if they have a chunk of rock, they can see how much of that radioactive chemical or element is left in the rock, and that can tell them how old the rocks are. And so they know that the oldest rocks that they've ever found are around 3.9 billion years old. And the oldest fossils, and a fossil is any trace of life preserved in rock, the oldest fossils that have ever been found are about 3.5 billion years old. Right? And these are the oldest rocks and the oldest fossils. Okay? The oldest rocks I've ever found is a type of rock called tonalite gneiss, and you can actually find some of this in Central Park in New York City. And the oldest fossils are stromatolites. Now, stromatolites, they look pretty big right there, but they're actually pretty tiny. And it's actually a clump of fossilized bacteria. So a massive bacteria that has actually fossilized. But bacteria are cells. And so we have the oldest known cells and the oldest known rock. So they think somewhere between getting a group of cells that were living together and just plain rock, we got the first cells on the planet, so we got life. All right? So the history of the Earth, as scientists have set it up, is broken up into 4 eras. And those 4 eras are what actually make up the geologic time scale. All right? And those 4 eras are the Precambrian era, which is from the beginning of the Earth, about 4.5 billion years ago, to 540 million years ago. So by far the biggest era. Now the Paleozoic era is the one that they set from 540 million years ago to 245 million years ago. Then there's the Mesozoic era, and that started 245 million years ago to about 66 million years ago. And then you have the Cenozoic era. And that's the one that we live in right now. We are in the Cenozoic era. And the Cenozoic era started about 66 million years ago and is to the present time. And the fact that each one gets shorter has nothing to do with like the Earth winding down, okay? It's what scientists said, just based on the organisms that live there. So they just like pick an organism like this one, the Mesozoic, that's when the dinosaurs lived. So they just pick an organism and say, when these were around, this was our era. And so we are now in the Cenozoic era. Okay, so this is a time scale, and the blue part, the green part, and the orange part are kind of the scale for how scientists have set them as far as how long they are, but the brown part's missing a bunch. If you can imagine my classroom, and then take my classroom and go all the way across to Major Garland's classroom, all the way across the building, that's how you would have to draw that brown part right there to get the full scale of it. It was a very, very long time period when not a lot was happening until the very end of it. And then you keep going. In this picture, you can see some of the dominant life forms. So the things that were dominating the planet. And that is how scientists set up the time periods, is based on the dominant life forms. So here are your dinosaurs. That's what made it the Mesozoic period, were the dinosaurs. The dinosaurs disappeared, mammals took over the earth, like us, okay? And that brought us into the Cenozoic period, when the dinosaurs were gone and the mammals took over, right? And so that's what we're talking about here. These divisions are separated by the organisms that lived during that time period. And we know what lived because of fossils. And index fossils are what are used to identify and define those geologic periods. If you find a dinosaur fossil, you know it was the Mesozoic period. Okay, that's basically what we're talking about with an index fossil. They have a species. If you find the fossil, you know exactly what time period you're looking at. That's how we use index fossils. So they work because although layers of sediment may look different, and they can even be, y'all, in totally different countries, totally different depths, it doesn't matter. The sediment might be different, the depth might be different, but if you have that organism, they work because they can include the remains of the same species. And once you find that species, you know what time period you're talking about, right? And so that would mean that they are from the same time period, since different organisms live at different times. But the same organisms live around the same times, right? Now, the boundaries between these geologic time periods are also often marked by mass extinctions. Now, mass extinction is when an entire group of organisms disappears from the fossil record almost at once. Now, almost at once, when you're talking about 4.5 billion years, is not really quick, okay? It took a couple million years for the dinosaurs to disappear. But geologically speaking, when you're talking about the history of the earth, that's really quick, okay? But it's not quick like we think of quick, all right? So when entire groups disappear, that's a mass extinction. And of course, everybody knows about the dinosaurs disappearing. That's the most famous mass extinction. So a good example to think of for a mass extinction is the dinosaurs disappearing. There have actually been a lot of different mass extinctions in the history of our planet. These are just a couple of them. Okay, the end of the Ordovician, the end of the Devonian. The end of the Permian was actually the biggest one that scientists have ever identified. This was before the dinosaurs showed up, and they actually think that up to 95% of all life on Earth disappeared during this one. It was nowhere near that bad, okay, when the dinosaurs went extinct, which was at the end of the Cretaceous, right? And so that's what mass extinctions are. Between the organisms that were living here and dominating the planet, okay, those index organisms, which made the index fossils, and then those organisms disappearing in mass extinctions to make way for new organisms, the scientists were able to divide up the history of the Earth into time periods to create the geologic time scale. Now, the scientists who give us all of this information are our paleontologists. And the paleontologists are the scientists who study ancient life, and they are the ones who give us facts. If they actually dig it up and put their hands on it, that's a fact. And theories, all those inferences they make from those facts. They give us theories and facts about the evolution of life. Y'all have a great night.